Hi guys, today I'll be attempting to solve Leetcode 347, which is top k frequent elements. So if we're given an array, in this case nums, and an integer k, so we need to return the k most frequent elements. So when I see the first example, I notice that the frequency of the number 1 is 3, the frequency of the number 2 is 2, and the frequency of the number 3 is 1. And the value of k given to us in this case is 2. So basically, we need to return an output which is of length k, and it needs to contain the numbers which had the maximum frequency in our original array, in this case 1 and 2, because 1 had a frequency of 3 and 2 had a frequency of 2. So we return 1 and 2 in this case. A base case probably could be when we have a single element and the value of k to be 1. In that case, we return 1 itself, because 1 occurs one time, and that is the maximum number of elements which occur the maximum number of times in that given array. So that's a good base case to start. The problem would be solved by using hash maps and key value pairs. So I'll do it that way. Also, initially we do take a count, basically a counter for doing these things. So in this case, we would have our counter set as an initial value. Sorry, yeah. And we would need to count frequency also, but in this case, we'd have a list of null arrays because initially we need all of that. So we do that, and when that's true, we take in a range of all these arrays. So I have prime range. This is len of nums, I believe. Yeah, plus 1. Yeah, that should be the frequency of a given set of null arrays. So we do that, and now we say for n in nums. When that's true, we make sure we start counting. So again, we use our hash map concepts here. 1 plus count dot get. Our value in this case would be, we could put 0. That would be a good condition here, because what if n does not exist? We don't know if n exists or not, right? So this would return 0 if n does not exist, which is a good condition because a count would be 1 in that case. So we keep it to that, and we now have to have another for loop, which would be of two things, right? Because we'll have n and the count also. So we'll have that in count.items. And when that's true, we need to append the frequency which we've counted. So frequency of C, that needs to be appended. Sorry, append to n. Right. Now we create a result array, and we go from in this case we go in descending order because we need to print elements which have the maximum frequency. So for I in range, so we should have length of the frequency minus 1. It goes to 0. The decrement is minus 1 because it steps through the entire thing from length of frequency minus 1 to 0 by following minus 1 as a decrement. So when that's there, oh sorry, this again. Yeah, when that's there, for every n in frequency of I, sorry, yeah, we append that on the result. We end. Yeah. Now we need to have a condition where this stops, because this needs to also stop and return eventually. So the stopping condition is the value of k, because the array length would be as long as the value of k is, right? So we could do this: if length of the result equals k, and we're done, I think, in that case, because that's the case when we return what our array is. So we return res, and that's probably the only return, because if we have to return res, that's the only place we'll do it if that condition is satisfied. So this was more or less it. If we run this, then we kind of get that, okay, that's invalid syntax. So maybe if I could, hmm, maybe, what if I do, sure. Hmm, what is it? The definition of the frequency in this case is a list of null arrays. Why is it wrong? Um, yeah, maybe, uh, if we could, okay, I think that's an issue I need to sort. I'm not too sure if I could fix this right now. Wait, okay, I need to make sure this works. So yeah, I'll fix it for sure and I'll let you know. But I think the logic which I've applied here should work out, and the methods I've written also should be fine. So yeah, I'll get back to this for sure. Thank you.